Hey guys, today we're going to continue talking about percents and how to turn a percent into a fraction and as a decimal. So your student outcomes are students write a fraction and a decimal as a percent of a whole quantity and write a percent of a whole quantity as a fraction or decimal. Okay, so for example, if you take a fraction like, let's say 7/10, and you say that as you read it like 7/10, you don't read it as 7/10. The mathematical way to read it is 7/10. You can write that also as a decimal, 7/10. This is the tenths place. And you can also write it as a percent. But the problem is percents are all out of 100. And so this only is out of 10. In order to make this so it's out of 100, we would have to multiply this by 10 and multiply this by 10, which would give us 70 hundredths. And now I can write this as a percent because it's out of 100. That's the key. So this is 70% because it's out of 100. This is still 70%, but a lot of kids will take and they'll write 7%, and that's a common mistake I see. It is not out of 100, so you have to add a 0 onto both of these, which is like multiplying by 10 to give you 70%. So that's kind of what we're going to do today, is transfer between decimals, fractions, and percents, all of those three things. Let's start with this example. It says Sam says 50% of the vehicles are cars. Give 3 different reasons or models that prove or disprove Sam's statement. Models can include tape diagrams, 10 by 10 grids, double number lines, etc. So we're going to first start off with, if you look here, it says that he says 50%. Now 50% is half of 100. So if we take 50% and we put it over 100, we can scale this down. We can divide these both by 50, which gives us 1 to 2. That would mean 1 for every 2 trucks is a car. Now, if you can see here, I have 1 for 2 trucks, and then I don't have 2 more trucks for this guy or 2 more trucks for this guy. So 1/2 is not the correct answer for this. So this is one way to disprove Sam's statement. By the way, too, real quick, dividing by 50 is the same as cutting off one of these zeros. Since this has a 0 and this has a 0, we can take one off and cut it right down to 5/10. And you should know that 5 is exactly half of 10. Another way to prove this or disprove this is we could take and we could draw kind of like a tape diagram where we have 3 cars and 2 trucks. So I would break this into 5 parts because there's 5 total vehicles. I know that this is car, 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 and this is truck, truck. So if I know that all percents are out of 100, the whole box is 100%. Now, if that's 100% and there's 5 boxes, that means in each box, this would be 20, 20, 20, 20, and 20, because 20, 40, 60, 80, 100 is 100%. So you can see here that the 3 cars from here to here is 60%. Now, Sam said 50% of the vehicles are cars. So we just proved that Sam is incorrect, and that's how. Another way how, okay? The next method that you could use is you could say, okay, well, I count here, there's 3 cars. If I want to make a little proportion here, I can do cars over trucks. I've got 3 to 5, or I'm sorry, 3 cars to total, 3 to 5. And if I'm trying to, I know all percents are out of 100, the total for percentages is 100. I know that 5 times 20 is 100, so I would do the same to the top, which would give me 60%, because 60 out of 100 is 60%. So there we proved him wrong again, because he said it's 50. So we did our 3 ways to prove Sam wrong. All right. Now, on the back of this, we kind of already answered these questions. Oh, how is the fraction related to the percent? Oh, we already used models. We're going to skip this part here. So we're going to go ahead right to example number 2. All right, and example 2 says a survey was taken that asked participants whether or not they were happy with their job. An overall score was given. 300 of the participants were unhappy. Let's underline that. 700 of the participants were happy. Give a part to whole ratio for comparing happy participants to the whole Then write a part-to-whole ratio of the unhappy participants to the whole. What percent were happy and what percent were unhappy? So we have lots to do here. I'm going to go back to the beginning. It tells me that I need to make a ratio, part-to-whole ratio, for comparing happy participants to the whole. So if I look back, this is 300 that were unhappy. This is 700 that were happy. So we're going to do 700 over. Now, it says part to whole. Well, how many total people were surveyed if there's 300 that were unhappy and 700 that were happy? You should have said 1,000. Okay. Now, if we have 700 over 1,000, that's going to be a little tricky because we're not going to figure out the percent yet, but we will get to that because percents are out of 100. We're going to talk about that in a minute. Let's do our unhappy ratio. So our unhappy ratio is 300 people to the total of 1,000. Okay. So we've got that. Now we need to create a model to justify our answer. Now, if we know, I can do a double number line. So let's do that. We're going to draw a double number line. This is going to be our percentage. This right here is going to be our participants. Whoops. So over here at the end, I know I'm going to have 100% as my total, and my participants, I know my total participants are 1,000. Now I'm going to also start with zeros here. And 100%, I know I got to count up by hundreds here. I'm going to count up probably by tens up here. So like this is 1/10 of this. So 10 over 100. And then I'm going to do 20, 200, 30, 300. Keep going. And there you go. So now you can see here the number of percent that are happy. So if you look here, 700. So if we look at 700, we can see that's 70%. And if we look at 300, we can see that's 30%. Now there's another way you could have done this without the model. Since you know all percents are out of 100, you could have just taken off 1 0 here and 1 0 here since they both share a 0 to get down to 100 here. And then since you have 70 over 100, that's the percentage. Same here. It's out of 100, so we know 30% is the answer. Okay? All right, we're going to move on to the next example, exercise 1. Renita claims that a score of 80% is the same as the fraction 4/5. She drew the following picture in order to support her claim. So here's her picture, except you can't really see it here. This is all supposed to be shaded. So would you take a minute and shade in the first 4 rows of this? That's supposed to be shaded. So now that is 4/5. This is 1, 2, 3, 4 out of 5 rows that are shaded. So I'm going to circle that. Okay. But she claims that 80% is the same as 4/5. So we want to prove if she's right or wrong. So if you look here, this whole thing, you have five boxes here, and you have, I think, 20 boxes going across. So 20 times 5 is what? Go ahead and figure that out. If you said 100, you are correct. So 100 total boxes in the whole diagram. And if you do 4 of the rows, that would mean 20 times 4, which would give us 80. So now all percents are out of 100. If I have a total number of 100 boxes in this whole chart, and 80 of them are colored, would that mean that that's 80%? And is Renita correct then? 4/5, 1, 2, 3, 4 rows out of 5 is equal to 80%. And the answer is yes. And it says why or why not. We're gonna show. So we can show 4/5, and we want to try to get up to 80%. Now, 80% would go on the top because I know 100 would go on the bottom. If you multiply this by a number, is it the same number that you would multiply this by to give you 80? What number times 5 would give you 100? Is it the same number to give you 80? If it is, then Renita is correct. It is 80%. So hopefully you said 20, and 80 hundredths is the same as 80%. So she is correct. Okay, Next problem. It says, use the tape diagram to answer the following questions. So if you look here, this is 0, and these are percents. This is 1 part out of 5, 2 parts out of 5, 3 parts out of 5, 4 parts out of 5. You have to remember that it's out of 5. Down here, 20% out of 100, 40% out of 100, 60% out of 100, 80% out of 100. So it says 80% is what fraction of the whole quantity? So if you look here, 80% is 4, but it says what fraction? 4 what? 4/5. 4/5 of the whole quantity. It is 4 parts out of 5. Okay? 80% is 4 parts out of 5, and we just proved that right up here. 1/5 is what percent of the whole quantity? So if you look, 1/5 is 1 part out of 5. We're looking right here, and that's 20%. 50% is what fraction of the whole quantity? Now, 50% is halfway across. So when we look at 50%, 50% would be in the middle of 2 and 3. So that would be 2.5 out of 5. So we would write that as 2.5 over 5. Or you could write it as 2.5 over 5. Either way. And then this is the trickiest one. 1 whole is what percent of the whole quantity? And a lot of kids will tell me 20%, but that's 1 out of 5. So that's not 1 whole, that's 1/5. 1 whole would be 5 out of 5 parts, which is 100%, because 5 out of 5 is equal to 1 whole, and that's equal to 100%. So I hope that made sense to you. Okay, the last page is on the back, and we're going to do number 3, and then we're going to do the chart at the bottom. So it says Maria completed 3/4 of her workday. Create a model that represents what percent of the day Maria has worked. So we can draw a box, kind of like a tape diagram, and we can divide it into how many total parts. You get your total from your denominator. So pause the video and break this into the number of parts that you think you should break it into. Hopefully you broke it into 4 parts. 3 lines makes 4 parts. And if we know she's completed 3 out of 4 parts of her workday, we're going to color in 3 out of 4. Okay, that's our diagram. Now it says, what percent of her workday does she have left? Well, if I know the whole thing is equal to 100%, because all percents are out of 100, and I break each of these, divide it by 100 divided by 4 parts, that's going to give me what percent for each box. I want you to write it above each box. Hopefully you told me 25. If you think of quarters, that's 25 cents, and you know $1 is 4 quarters. So what percent of the workday does she have left? If you notice here, the only box that's empty is 1, so that's 25%. And you have to write the percent sign because it asks you what percent. Now it says, how does your model prove that your answer is correct? And you can see, we can say my model shows 75% equals 3/4, and 1/4 left is 25%. That's pretty evident up here. 1, 2, 3 is 75%. 1 left over is 25%. I hope that makes sense. All right, so sometimes you may not be able to multiply the denominator by a number to give you 100. In this case, you must divide the numerator by the denominator to make it a decimal. Then move the decimal 2 places to the right to make it a percent. So that's where it gets a little tricky. Now, in this case, we don't have a multiple of 10 here. 10s are easy to get up to 100. We can multiply by 10. We can multiply by, any kind of number. But when you have an 8, you can't really multiply by anything to make that a decimal. So what you have to do with this in order to make it a percent is you have to divide the numerator by the denominator. Now, this is where it becomes tricky. A lot of kids think you can't divide the bottom number by the top number. But in all actuality, guys, anytime you divide, the top number always goes in the house first. All you do is add a decimal and a 0. So we're going to divide this out. 8 goes into 30 3 times. It gives us 24. We're left with 6 because we have to borrow. Add another 0, bring it down. 8 goes into 60 7 times. That gives us 56. We have to subtract, borrow. We get 4. Add another 0, bring it down. 8 goes into 40 5 times. So we get 375 thousandths for our decimal. You should always have the placeholder 0 in front if there isn't a whole number there. Now, to change that decimal to a percent, when you're going from D to P, you move right 2 places. The way I tell kids to remember that is, think of the alphabet. If you're going from D to P in the alphabet, you're going right. So when you move why you move 2 places is because it's 100. There's 2 zeros in 100. You're multiplying by 100, really. When you multiply this by 100, you move right 2 places. So the percent would be 37.5%. And you learned that last year in 5th grade, powers of 10. Now, we went from a fraction to a decimal to a percent. Now we're going to move from a decimal back to a fraction and then to a percent. Now this, I would recommend if you're starting with a decimal, you read it out loud to yourself. So here's 35. I read it as 35 hundredths. So when I say 35 hundredths, I write the fraction just like I say it, 35 hundredths. Now, when I write that as a percent, since it's already out of 100, I just take that 35 and put a percent sign on the end, and voila, I'm done. Now I have the percent and I'm going to the decimal. Now when you go from a percent to a decimal, that's backwards. So you're going to move left 2 places. You're dividing by 100. So you're getting smaller. The decimal will be 0.845. 0.845, 845 thousandths. Now, when I read that, you noticed that I said 0 and 845 thousandths. That means I'm going to put 1,000 underneath this number. And that's how I would write that. Okay? Again, this one, I'm going from a decimal to a fraction. All I do is read this. 325 thousandths. That's how I write it. Now to make that a percent, we're going to move it right 2 places. So boom, boom, that gives me 32.5%. And then the last one is a fraction. And actually, if you look at the denominator of this fraction, it's not necessary that we divide like we did in this one. We couldn't get from 8 to 100 in this case. But if you notice 2 over 25, we can get to 100. We can multiply this by 4 and do the same to the top, which gives us 8 hundredths. So this is the same as 8 hundredths. Now, when you write that as a decimal, it's pretty easy. 0.08. I said 8 hundredths. The 8 has to go in the hundredths place. The last digit you say before the place value is the digit you need. Oh, and then this would be 8% because it's out of 100. So that's it for today. We're going to practice this more in class today, but thanks for watching now. Have a good day.